Thanks. I'm Narayanan Lakshmanan, and I go by Nana, an engineering manager for PowerShell desired state configuration. I'm mostly going to be standing here and talking because I have some affinity towards code, so I'm going to show some code here. I assume people in this room are using Windows in some form. So is everyone familiar with PowerShell? Show of hands, please. Good. Have people used DSE here? Great. So we are at the right audience, and for those who haven't, DSE is nothing but it's still PowerShell. You would do DSE using PowerShell, and I will walk you through some portions of it. So let's get started. Let's first look at why DSE, right? Pretty much if you think about in terms of managing Linux systems, right? The thing is, by doing two primitives, you could pretty much do anything on Linux, right? Modify a file and restart a process, and pretty much anything can be done. Windows is a drastically different world, right? There is a large API surface. We have PowerShell commandlets, there is .NET, there is WMI, COM, XEs. You know, Windows is known for its large API surface. And PowerShell as a platform is actually, it's a glue that's designed to bind together this API surface. So that's what PowerShell is pretty good at. It binds together all of these. You know, it's built on top of .NET, works pretty well with WMI, works pretty well with COM, XML. You know, PowerShell has this concept of commandlets, and therefore it's natural, right, that DSE built on top of PowerShell is basically, it's a platform for managing Windows, right? And that's where tools like Chef come in. So we make DSE a platform play, and you know, you can build Chef cookbooks and solutions on top of it and get the value add. So that's how DSE is designed. And because it's based on top of PowerShell and because it's built into Windows, it's providing the best possible interface with this wide variety of API surface that we have in Windows. And obviously, because there is better binding characteristics, the performance when invoked is going to be much better. So the performance characteristics of using DSE with the Windows API surface is something that you can read. And then you know, you can consume DSE resources from Chef. So that's what in a nutshell we would talk about, you know, how to write a DSE resource and how do you actually consume it from Chef. Some of the concepts and tools that we will be using, you know, obviously GitHub for checking in, checking out code. We will talk about how to write DSE resources using PowerShell classes. Now there is another way of doing it. I'm probably not going to talk about it. This is the latest and greatest. It makes it very simple. If you've ever done any OO, this is pretty straightforward. Or even if not, if you're used to PowerShell, it takes a few minutes literally to learn about PowerShell classes. We'll talk about Pester. That's it's an open source PowerShell based unit testing framework, which we actually adopted and started to ship in Windows Server starting 2016. But it's also available for down level. You could go to the gallery, talk about a bit on how to consume that. So that's the unit testing framework. We'll talk about how to use Pester to test DSE resources. Then Script Analyzer, which is basically a tool that tells you what are the best practices that you need to follow for a script. And so we will look at how to use Script Analyzer to quickly look at some of the best practices for DSE resources. PowerShell Get, that's the platform through which we discover different modules in the PowerShell gallery, and then how do we publish to the gallery, because you know, this is the right audience, right? It's all about community-based development. So once you make a resource that's going to be useful, then how do you publish it and make it available for others to consume? And then finally, you know, how can we use Test Kitchen to do some integration testing, and then eventually lead to how do we use from Chef. So conceptually, here are the phases in terms of resource authoring. You basically first model a resource. So a resource is any entity that you want to get to a desired state. So it can be a primitive like a file, service, registry, certificate, through to you can start building higher layers of abstraction, something like SQL Server, IIS, SharePoint. Now anything that you can model with a set of properties can become a resource. So first is you model your resource, then obviously you develop it in PowerShell using PowerShell classes. and then you test it, use Script Analyzer to validate the best practices, and you finally publish. I have a few slides for reference. I'm not going to talk much through them because it's always great to be looking at code. But a couple of key points, right? It's very important to model the resource correctly before writing any piece of code. That is something that even we in the PowerShell team, learn by practice. Is always, take a few moments to model your resource correctly. What are the set of properties that you want to configure, and it saves a lot in the long run. So basically, the 4 principles, right? A resource need to be uniquely identifiable. We'll use what's called as key properties in DSC to identify them. For example, a service is uniquely identified by its name. A file is uniquely identified by its path. A package is uniquely identified by its identifier, so on and so forth. So a resource should be uniquely identifiable. It should be expressible, which means the desired state should be expressible independent of the control flow. For example, the state of a service, whether it's in the running state or whether it should be in the stop state. Now that's expressible state. Restarting a service is not. That's an action. More often than not, people confuse actions with state, right? You restart a service, but that's an action that you do, and the state actually is it's in the running state. Then obviously it needs to be testable, which means you are able to accurately test if a resource in a desired state. Is a service running? Is it stopped? Is it startup type manual? You're able to test it, and you can enact it, which means you will be able to actually get the system to the desired state, right? Updating the kernel is not something Windows supports, right? So that's not enactable. Starting a service, stopping, setting up SQL, setting up SharePoint, those are like enactable ones. So those are some of the principles that any resource needs to satisfy. And then we'll talk about what the different kinds of properties, etc., as we start writing some code. I've just thrown in them here basically for a reference as we move along. So now let's get down to how do we write resources using classes. So here's my Windows PowerShell ISE. I assume this audience is fairly familiar with what this is. So we basically, open up ISE and we can start writing a PowerShell-based resource. So what do? The first is you declare a class. So we're going to write, let's say, the resource that the simple example we're going to use is we're going to model a Windows service, right? So the service is going to be identifiable uniquely with its name. So that's one key property it's going to have. You can specify the state of a service, whether you want it running or whether you want it stopped. And you can specify the startup type, whether you want it automatic, manual, or disabled, right? So let's go ahead and write this simple DSC resource. So here we have class Windows service. So this is a simple class declaration. And then to make it a DSC resource, what you do is you decorate it and call it a DSC resource. And you can immediately see a bunch of squiggly, the red underlining here, and it says it's missing a set get test method and must have at least one key property. And we will in a moment see what that is. So now we need to define the different properties that this resource is going to have. So it's going to have a name which is of type string. So you specify the type. Then we are going to decorate it and say this is a DSC property. So it's a DSC property, and you specify it as a key property. So that's the way to do it. So you use attribution to specify, this is the type, this is the variable declaration, and here is the attribution that makes it a DSC property, and it's a key property. So when you do get DSC resource, here is where it's going to pick it up from. And then we're going to have string state. It's a DSC property. It's mandatory. So the property can be of 4 types. The first is key, which uniquely identifies an instance. Mandatory, straightforward, it's a required property. If you do not specify anything, then it becomes a writable property, which means that is something that the user can configure, but it's not mandatory. Or the fourth type is something called as not configurable. So this is a property that the user cannot configure, but when you look at the current state of a system, the DSC resource will return it. A good example is the last modified time of a file. Now that isn't something that the user would configure, but in many cases, it's good to know when it was modified, because as we all know, change is the root of evil, so it's good to understand some of these. So whenever something is declared as not configurable, then it's a read-only property. So those are the four types that you can have. So here I'm going to mark this mandatory, and you can also use attributions like validate set. Like for example, if this takes only 2 values, so something like that, right? So this is how you start declaring the properties. Now we need those 3 methods that a DSC resource needs to implement. The test method says, given the set of properties, is the resource instance in its desired state? For example, in this case, if I am specifying the name and the state, whether it's running, then the method should check and let me know, let the system know whether the service is in the running state. And then the set method is, given the set of properties, it will make that particular resource with those set of properties, and get will return the current state of the system. So the easy way to add methods is test should return a boolean, so you say bool test, and you write in code whatever it needs to happen. Similarly, set is a void, so you say void set, and you can say write verbose setting to state whatever, some message, and then finally you could do the get method, which says Windows service, something like this. You could say return this, right? So this is, and then now it's like, if you're familiar with PowerShell scripting, you go ahead and fill in the code to actually make this happen. So I'm not going to write the whole code here, but I could show you how this is going to look like. So here's the full resource. By the way, I'll make all this code available in my GitHub repo, so you could go and download, play with it later. So here is the set of properties. There's a name, there's a display name which is not configurable, state, startup type. Here is the get implementation, there's a test, a set method, and you can also have in PowerShell class, this is just to show some of the concept, hidden. Hidden is, if you have a hidden method, it will not show up when you do a get member on the particular type, so it won't show up. So typically used for helper methods. So once you have all of this, you basically save the class in a .psm1 file, and then you got to include that in a .psd1. So here is an example PSD1 that I have. So the root module is the .psm1, and then there's a new property we have called DSC resources to export, where you specify which DSC resource you want to export. Now the reason it needs to be done this way is DSC resources are discovered by PowerShell at parse time, not at runtime. So in order to make sure that it is performant, what happens is it only looks through all the modules and looks through the manifest first to see which resources are exported, and only then starts to parse the .psm1 file. Otherwise, there may be lots and lots of scripts, and parsing means like you will not be able to do any useful work in ISE. So that's the reason why it has to be declared. So if the DSC resource to export field is not declared, then it's probably not going to show up when you do a get DSC resource. So this is the simple way in which you author a class-based resource. And once it is done, then you could basically copy this to, so I'm going to copy this to C program files, Windows PowerShell modules. And then now you could So the module is in there, and you can say get DSC resource. And you find here's the resource that we wanted, Windows service that we just authored. So this is the simple way in which you author a class-based resource. So just a quick recap. You start with the .psm1 file where you declare a class with the DSC resource attribution. Then you declare the set of properties with the DSC resource property attribution. You implement the three methods get, set, and test, and then you create the PowerShell module manifest, and you export the DSC resource. Again, DSC resources are PowerShell artifacts, so similar to other artifacts like alias, commandlets, functions, etc. They're always shipped in a PowerShell module. So that's the container. Now that we have looked at how to write a class-based resource, and let's look at how to actually test the resource using Pester. So as I said earlier, Pester is a unit testing framework that's actually an open source project that we have started shipping in Windows Server starting 2016, but it is available in the PowerShell gallery. How people use the PowerShell gallery here? Good. So a quick overview. PowerShell Gallery is the artifact sharing platform where we share modules and scripts. So to discover the different modules that you would want, so you would go and say find module. So by default it goes to the public PowerShell Gallery, PowerShellGallery.com. And so I'm going to search for module by name Pester. So it's telling me version 3.4 is available. You can also look at all versions, and it's going to tell you all the different versions available, so on and so forth. And then you could use install module to actually download the module onto your machine. Since you already have it, let's go ahead and do that here. So in Pester, if you want to write a new, so let's do this. Let me quickly. Okay. So let's go to, so create a tests folder. And then you say new fixture that creates the framework for you. Dash path dot dash name, let's call it service helper. So Pester creates these fixture files. So the first thing we do is we open the PS1 script, and within this we're simply going to import the module. And let's open up the, so here is the framework of Pester, right? Describe is more like a suite. It describes the test suite. So you go ahead and start filling code. So it says describe test for test method, something like that. And you can also add tags. So you can run tests by tags. And then this is basically a test case. So all you have to do is it. Here is the description. So you want to say test. Some sample. And one of the things about class-based resources is the type is only defined within the .psm1 file. So what I've done is I've added a helper function which will basically help me export the type out. So I have this new function here, new service. So that's the one I'm probably going to use. So I'm going to say, you could start writing here. $S is new service name state, and then you can say s dot test, whatever. So should be test for a Boolean condition, so you could test for different conditions, and that's about it. This is your first Pester test, and you could start writing. Pester also supports the notion of mocks. So if you have a commandlet that's actually changing the state of a system, you could define a mock saying, okay, I do not want to actually change the system, but do something which is the traditional unit test way. And here is the sample of the Pester test that I have. So you have blocks like before all and after all, which is script blocks that get run before and after all of the suites. You can also have before each and after that will get run before every test suite. So now here I have I'm testing whether the service is stopped. Then you could test whether the service is running when it is started. Here is the nice thing. So here is a set of test cases. I'm testing all the permutations and combinations, and you could specify a set of test cases, and that's basically from a hash table. So I'm saying test if this service is running, compare it against, and you could use those tokens to actually parameterize and generate a whole bunch of test cases. So that's pretty much the full testing. So once you have that, now let's go and actually run the code. So all you say is invoke Pester, and it's going to run all of the test cases. So invoke Pester, and it basically runs the test cases. So one of the things we highly recommend is, because DSA resources are always written and shared across with the community, we strongly encourage, and soon we will start requiring people to actually have test coverage, so we can validate the quality, and even the community before they consume can validate the quality of the resources before they start using it. And you can also measure code coverage. So I could say invoke Pester. You want to measure code coverage against this one. At the end of it, it tells you, what are the blocks of code which is not been tested by this test suite. So that comes in handy. So far in our development cycle, we started with modeling, then we are done the development of the resource using PowerShell classes, and then you write the test using Pester. And here are some Pester best practices. Again, I'm going to skip through them for now, but they are in the slide deck for reference. So next is, let's use Script Analyzer to actually validate some of the best practices to see if anything has been missed. So the way you look for Script Analyzer is you look for the module PS Script Analyzer. That's a standard practice we use in the team. Whenever we think there can be a collision in the name, we prefix it with PS. So that means the module is coming from the PowerShell team, right? So you go search for Script Analyzer, and Script Analyzer comes with two important functions, one of which we are going to use now. So what I'm going to do is I'm going to say invoke Script Analyzer against this file. And it's going to run a whole bunch of rules, and it's telling me, which of these rules are it's violating. And of course, there are some bugs in the latest version of Script Analyzer, so you would see some noise here, but essentially kind of get the idea. Let's pick something here, right? Like for example, null should always be on the left side of equality. That's more like a warning. It's a good practice. Some of these are informational messages. Like for example, get function in DSE should return object of type, Windows service. So that's okay. Let's go ahead and fix it. So you go in here, and you could go to the get. Oops. Let's get, yeah. So the get function is here. So you could say equals display name value name equals let's do this real quick. Let's do that, and you say return some value. Let's comment this out. So now if I go back, run script analyzer. Oops, I don't know why it's not fixed. Wrong one. There you go. So that one is getting fixed now. So now once we have this, so you could run by the rules, and whenever we are trying to publish a DSC resource, especially when we are taking it into our GitHub gallery, there is a prescribed set of rules that we have which we will run by to see if the script abides by those rules. Example, like you can't have plain text password, right? That's a rule that it'll automatically catch, and things like that. You can't have password like a string, for instance. It has to be of type credential, so on and so forth. So there's a exhaustive list that we maintain. So once you have this, now it's the next thing is to actually go publish it into the gallery, because now we have developed it, we have tested it, we made sure it adheres to all the good practices. Now how are we going to go ahead and publish? For which we are going to use a command called publish. Here is the PowerShell gallery. For those of you who haven't, so you could go to PowerShellGallery.com, and if you want to start contributing, you basically register and you would get your API key, and all you need is the API key to publish from the command line. So we go in here and say, so I'm going to say get module dash list service manager. So this is available in C program files, Windows PowerShell modules. That's where it's going to publish from. So we say publish module dash name service manager, and it's a NuGet key. I have my NuGet key. Oops. Okay, let me get mine. Now the worst part is putting out your key in a demo, but that's okay. Oops. Okay, now let's see if it's published. It takes a while to update, so let's come back to this.
Is there any locally hosted alternative to PowerShell galleries? You say that we had something specific that we wanted to describe and use DSC for,
Yeah.
but we didn't want to put that out on the public internet.
So the question is there a locally available alternative to the public PowerShell gallery? And the answer is yes. So PowerShell gallery is based out of NuGet server. So you could stand up a NuGet repository, or we also have a couple of blogs about how to stand up your own private PowerShell gallery. A lot of people we know of, enterprises specifically, have done that. So yes, you could do it. And the same set of commandlets would work. You just basically point it against your gallery, and you're good to go. So now that we have, done script analyzer, we have published the resource. Now let's look at how do we actually use Test Kitchen to test. Now Test Kitchen comes in handy, especially when you want to do integration testing. Think about non-primitive resources, something like SQL or SharePoint, where you may want to target different versions of the operating system and test against it. So that's when you start to use Test Kitchen. It comes in handy. So the way you do it in Test Kitchen is you first have to author a PowerShell configuration, which is very isomorphic to a PowerShell function. And then Test Kitchen, you then specify which configuration to run, and then which set of Pastor tests to go and run that. So let's look at a quick sample there. So here is my example. So I'm using the Vagrant proxy driver, so my VM is already up and running. The verifier you're going to use is Pester. You use the DSC provisioner. Here is the things around Kitchen DSC, and basically I'm going to use default. So what this is going to do is it's going to actually look at, there needs to be an examples folder, and in the examples folder there is a simple example that we have. So there needs to be a configuration with the name default. So it's going to pick this configuration up and it's going to run. So this is a simple config which is basically setting the state of the service, right? This is the Windows Update service. It's stopping it, setting the startup type to manual. So it will first run this configuration, and then it's going to look at the suite which I specified, the default, which is this. So test integration default. So I have the tests here. So there are like two tests, basically verifying the state and the startup type. And now let's look at how Test Kitchen can be used here. So because I'm using the proxy driver, kitchen create is basically more like a no op. But then when you do kitchen converge, what it does is it finds out what are the modules required for this particular configuration. So all of the resources, it copies those resources onto the VM. It then also copies the configuration, locally compiles it, and then applies it. So that's what Test Converge does. So now when you have a different set of systems, you want to test it on 2012, 2012 R2, on 2016. This is a nice way to actually go about doing it. So you define the different platforms that you want, and Test Kitchen is going to do all of the copying, compile, and setting up all the configuration in the kitchen converge phase. So and as you can find here, it has run the configuration. So this is the output from DSC. You could see the resources that it had used and what has happened. Then is the phase of kitchen verify, where what it does is it then copies the tests that we have specified onto that particular VM, and then it starts to run the tests, and you can find that here is the Pester output of those tests. So this is a Test Kitchen is a nice way to develop a resource, and you can, if you want to test it across a variety of platforms, this is a great tool to go about doing it. And it does all the copy, compilation, tests, and getting the results back. So now the last is the most interesting bit. Now that we have a DSC resource, how do we actually consume that from Chef? The combination of DSC and Chef makes a lot of things very powerful. The great example, I'm not sure how many people got to see yesterday, is chefing SharePoint, right? So we have these great DSC resources for SharePoint, and then Target ended up developing Chef cookbooks on top of it to completely automate the process using the Chef workflows. So it's pretty easy. So you basically so there is something called as DSC underbar resource that's available in Chef. So you use that and you specify what is the resource that you want to use. So in this case, I want to use the Windows service resource, and you specify which module this resource is coming up from. So you say module name service manager, and then every property you want to specify, you use property and say, okay, name, I want this, state, I want this, so on and so forth. So this is the way in which you can consume a DSC resource from Chef in a Chef recipe. Now to see this in action, let's actually look at get service. So this is in the desired state, so I'm going to probably start this so we can actually see Chef in action. Then I'm saying Chef client dash dash. So as you can see, first the Chef engine loads the resource and calls the test method on it, and looks at what the test method is. So this is the output from DSC engine, right? It shows you what module is imported, and the test method basically return false, which means the resource is not in the desired state. So now Chef invokes the resource again and now calls the set method with the desired set of properties, and you can see that it's actually being set into the desired state. So now when you run it again, you're probably not going to see any output because the system is already configured the way it is. So this is how you consume a DSC resource in Chef. So it's already up to date. So here are some of the what we call as key aspects to follow when we are looking at high quality resource modules. You got to make sure that the script analyzer rules are clean, especially based on the resource kit severity rule. We want to make sure that there are tests present for every resource, and you at least have about 70% coverage. That's a reasonable number. No science behind it. We just thought something reasonable, so 70 was what people were comfortable with. And there are examples present, because most times people start to consume a resource by looking at examples. So examples are key, and it's good to have real-world examples. There is clear and thorough documentation, and it follows the module structure. So basically, what we want is there is the resource, and then there is an example folder containing examples. There is a test folder containing tests. The documentation is written using Markdown, so on and so forth, right? And then there is style guidelines. Simple things matter, making sure all the properties align, that makes the code more readable. Following, best practices in terms of naming conventions. Those are small little things that add up whenever it comes down to community. So we do have DSC resources being developed in the open source community model. So you could go to github.com/PowerShell and you could find all of our open source projects, including DSC resources in there. So feel free to contribute. You could, pick an issue as a good place as a starting point, and send in a pull request to get your hands on. You can also author new resources and transfer ownership, or you could take a fork of it and make changes, keep it private. Everything is welcome, right? This is developed in the community model. And of course, if you are using, if you want to use the DSC resource with Test Kitchen, for instance, feel free to ship it with the Kitchen YAML, and it can go into the repository. As far as PowerShell is concerned, that's just another file, so it really doesn't matter. You can kind of download the sample code. Not sure if it's available here. It's github.com/nanalakshmanan/chefconf2016. the code is available here. You can just download, play around with it. And here are some useful links. How do we get started with GitHub? How do we write a resource, our open source work, just for reference for people who want to contribute. With this, we are pretty much at the end. Any questions? The slides, are they going to be available? Yes, I'll just upload them as soon as I'm done. So the question is, you're writing a lot of PowerShell scripts, and when is a good time to move them into DSC? If your scripts are doing things like collecting a whole bunch of logs files, they're pretty much good to remain as scripts. But if your scripts are using for like configuring systems, like setting up services, setting up websites, setting up applications, then that's a good candidate to rewrite those scripts as I wouldn't say rewrite, refactor those scripts as DSC, because when you think about it, a DSC resource is nothing but you're kind of separating your intent from the imperative code, and it's in some sense it's a pattern of programming. So those would be good candidates to migrate. People have a lot of scripts in terms of setting up their applications, for example. Those are good candidates to go down the DSC route. But if you're using scripts for diagnostics, sometimes it's great to write some of these diagnostics tests as pester tests. We call them operational tests. Is your service up and running? You can write them as pester tests and hook them up. That's one other refactoring that you can potentially do. So the question is DSC faster than PowerShell? DSC, the agent, the engine which is actually doing the action, is indeed loading and running PowerShell. So it's as fast as PowerShell. It cannot be faster, because we are like loading and executing PowerShell scripts, if that's what you meant.
So is it an abstraction layer on top of PowerShell?
You can think of it as...
I think of PowerShell as an abstraction layer on top of .NET.
PowerShell is an abstraction layer on top of .NET. So DSC has two components. One is the language pieces, which is, you have extensions in PowerShell. And then the other is the agent piece, which we call as the local configuration manager, which takes a document with that and invokes all of these resources, makes the system into the desired state. Now the agent is actually loading PowerShell and executing PowerShell scripts, because if you think about it, your resources are nothing but PowerShell scripts. So the agent is, in some sense, loading PowerShell and running those scripts for you. So the question is, do they work inside containers? The answer is not yet, but containers is, as you know, is a work in progress. So watch out that space. Thanks a lot. Thanks for your time.
Thank you so much.